Okay, so on page 731, number 38, says a battery has an EMF of 15 volts. So that's our script E is 15 volts. And an internal resistance of 0.08 ohms. So that's our little r, 0.08 ohms. What is the terminal voltage if the current is 2.5 amps? So I is 2.5 amps, and it wants to know what's VT. So first step, you can find VI in T, the internal voltage. It's equal to IR. So it's equal to 2.5 amps times 0.08 ohms. So you get a VI in T to be 0.2 volts. And so then you go to terminal voltage is equal to the EMF minus the VI in T. So the terminal voltage is equal to 15 volts minus 0.2. So the terminal voltage is equal to 14.8 volts. Part A. Part B says, what is the terminal voltage when the current is increased to 5 amps? So now I is 5 amps. So I'm pretty sure that's going to make VI in T twice as much, right? 5 amps times 0.08 should be 0.4. And so then over here, V terminal is equal to EMF minus VI in T. So 15 volts again, but this time minus 0.4. And so you should get 14.6. So this goes back to us saying that the V terminal voltage is going to change depending upon the current. So when the current is bigger, you're going to lose more to the internal resistance, and you're going to have less left to use in the circuit. All right, number 39 says a battery has an internal resistance, that's little r, of 0.12 ohms. The terminal voltage of the battery, so this time they're telling us VT, and they're saying it's 10.6 volts when a current of 7 amps flows through it, when I is equal to 7 amps. So in part A, it wants to know what would be the EMF. So again, you can find the VI in T, the internal voltage. It's just I times R. So 7 amps times 0.12 of an ohm. So it's going to be 0.84 volts. And so now we know that VI in T is equal to EMF minus the internal voltage. So, this is VT, excuse me. VT is equal to EMF minus VI in T. So we're looking for the EMF this time, so bring this over. So the EMF is going to equal the terminal voltage plus the internal. So the 10.6 volts they gave you plus the 0.84 volts you just found. And you should get an EMF of 11.44 volts. Part A. Part B says, what would be the potential difference of the terminals if the current was now 2.2? So in B, I is going to be 2.2 amps, which means your VI in T, which is IR, is going to be 2.2 amps times 0.12 ohms. So you get a VI in T of 0.264 volts. Okay, so now you're going to use that in your equation. V terminal is equal to EMF minus VI in T. So in part B, they're asking for the terminal voltage. The EMF is what you found in part A. Remember we said whatever this battery is, 1.5 volts, that's its EMF. That doesn't change. And so what you found in part A, you use in part B, it becomes 11.44 volts minus 0.264 volts, and you get a terminal voltage of 11.176 volts. Okay, so really the point there was to see if you could tell the difference from between the different V's. Okay, on to power. On page 737, number 40 says, an electric toaster is rated at 875 watts. So number 40, power, 875 watts. And voltage, 120 volts. Calculate the current the toaster draws when it's on. So P equals IV, I equals P over V. So 875 watts divided by 120 volts should give you 7.29 amps. Part A. Part B says calculate the resistance. So you could do V equals IR. So R is equal to V over I. So 120 volts divided by that 7.29 amps. And you have all the digits in your calculator there. And you should end up with 16.46 ohms. Okay. Number 41 says a light bulb designed to use with 120 volt power supply, 120 volts, has a filament with a resistance of 240 ohms. What is the power output of the bulb when with the potential difference of 120? So power is equal. Now I would probably use V squared over R. Okay, so 120 volts squared over 240 ohms. One of them cancels, 120 over 2, and you should get a power of 60 watts for A. B says, if the light bulb inadvertently is connected to an 80 volt power supply, what would be the power output? So this time V squared over R, and it's 80 volts squared over 240 ohms. 80 goes in there once, gives you 3 on the bottom. 80 divided by 3 should be 26.6 repeating watts. Okay, so that's the one where if you're changing the voltage, it's safer to use well, and here they gave you the resistance. Oh, there's a C. If you wanted to construct a bulb to use the 80 volt power supply so that it would have the same power output as a 240 ohm bulb connected to a 120 volt power supply, what should be the resistance? So in other words, in part C, they're saying the power is 60 and the voltage is 80. And they want to know what does R need to be. So P equals V squared over R. So R equals V squared over P. So 80 volts squared over 60 watts. And you should get an R of 106.6 repeating ohms. Now it's 42 for real. It says the heater has a resistance of 15 ohms. If the heater is drawing a current of 7.5 amps, what is the power? So power is equal to I squared R. So 7.5 amps squared times 15 ohms. Power is equal to 843.75 watts. And B, if the current in the heater is cut in half, what would happen? So if you half it, you should quarter the power, right? And so you could just do that divided by a quarter to get the new power should be 210.9375. Or you could actually put 3.75 in there and square it. All right, next page, 740, number 44. We're going to run out of time.